In this video, we'll introduce the batch processing recognition demo in ABBYY FineReader Engine, look at where the project is located, run the solution, and review the user interface and the benchmark results it produces. In this demo tool's batch processing recognition sample project, processing with only one core is compared to processing with the multiple core option. The project we are referring to is located in the Batch Processing Recognition subfolder of the Demo Tools folder. Inside the solution, let's open the Batch Processing Recognition C# file. Now, let's run the solution. You can see a simple dialog form appears. It allows us to choose a few parameters before we start processing the documents. Among the settings available in this user interface, we can select the directory where the documents to be processed are stored, choose the recognition language from the drop-down list, specify the maximum number of processing cores available for the engine during this demo, choose whether we want to export the results, and if so, select a destination directory. We'll proceed with the default settings, except for the export destination. Let's enable export and keep the suggested default option. The input folder is located in the Sample Images subfolder of the FineReader Engine deployment. In this demo tool, the documents from the Multiprocessing Recognition subfolder are used. This set of documents represents a batch to be processed with FineReader Engine. Now, the export results will be placed into a Results subfolder inside the image source folder. We'll see this Results folder appear during the demo. Okay, we are ready to go. To run the demo, we just need to click the Start button in the dialog. Here, the Results folder appears automatically as soon as we start the program. And here, we see the processing progress. This scenario compares processing on a single core versus a multi-core setup, in our case, 4 cores. Once the run finishes, we see a diagram showing the performance of the engine when processing the document batch with only one core versus splitting the same task across the defined number of cores. You can see that multi-core processing is more than twice as fast as single-core processing. Now let's have a look at the results folder. All input documents should now be converted to PDF, and here they are. Because the application actually processed the documents twice to compare one core and multi-core performance, each file appears twice. The file names indicate whether they were produced by sequential processing, meaning one core, or parallel processing, meaning multiple cores, in our case, 4. The recognition quality is the same in both cases, because the code uses the same processing profile for both scenarios. In this first video, we've seen what the batch processing recognition sample does in practice, where the project is located, how to run it, how to configure the demo, and how do results compare between sequential and multi-core processing. In the next video, we'll move from the user interface to the implementation and walk through the code behind the sample step by step.